Hello, today we're going to talk about significant digits, and we're really going to start off by saying there are two types of quantities that are usually used in science. Those would be exact values, the type of quantities are either exact values or measurements. The exact values are something like defined quantities. Let's say 1 meter is equal to 100 centimeters. We know that that's true. That's a defined quantity. Exact values also include counted values. Something like 5 beakers is something that I need in order to complete a science experiment, or in order to make my lunch, I need 5 tablespoons. Tablespoons, I don't know how to short form it. Measurements is really where uncertainty comes in. So there's no uncertainty here. And if there was any talk about significant digits in these exact values, whether they be defined values, as in 1 meter is 100 centimeters, or I'm using 5 beakers or 5 tablespoons, I will always say that I have infinite significant digits, infinite significant figures in exact values, okay? Now in measurements, that's where uncertainty comes in, and this is where these significant digits really also come into play, and they help us round answers correctly, okay? So let's go ahead and look at these significant digits and how do we really use them. So before I tell you the rules, there are a ton of few rules, about 4 or 5, I guess, with significant digits. Let me just write down a few numbers. 32.07, 0.0041, 7,002, and then I'm going to write 6,400, and 6,400 with a decimal, and then maybe, I don't know, maybe 6.0000. So how many significant digits do I have for each one? So here's a first measurement, and I should say that all non-zero numbers are significant. So that's kind of like the first rule. All non-zeros are significant. Okay. So in this first digit, I have 30, or this first number, I have 32.07. The zero is kind of sandwiched in between my non-zero numbers, and it kind of suggests that it was involved in the measurement. So I actually measured 32.07. I must have measured the 0 since I measured something after the 7. So all 4 of these numbers are significant. So that's kind of like the rule number 1. If the 0 is in between somewhere, in between non-zero numbers, it's significant. Doesn't matter where it occurs. The second one is 0.0041. And you can argue with me and you can say, well, this is like, well, I have 1, 2, 3, 4, 5 significant digits. But that's not true. Here I actually only have 2 significant figures. And you might say, well, I mean, why aren't these leading zeros, that's what they're called, leading zeros, why aren't they important? And they're kind of just there to be a placeholder. They're really just holding the spot so that I can kind of show where my decimal is. I'll show you this. If I had 0.0041, if this was kilometers and I wrote it in meters, I would have to multiply it by 1,000, of course, and this would become 4.1 meters. So you see here, when I write it in meters, I only have 2 significant digits. The zeros are gone, right? So they're actually not significant. They're just there to kind of hold my place value, my decimal, all right? So 2 significant figures for that one right there. And then I have 7,002, and I already said that. I said if a 0 is in between non-zero digits, as in the first example, it is significant, and it holds true whether there's a decimal or not. So there's 4 significant figures here. The next 2 are kind of tricky, and I'm just highlighting the fact that one of them has a decimal, the other one doesn't. If there's no decimal, so the first case here, 6,400, you don't really know if that's been rounded. You don't know if the person rounded to 6,400, was it maybe 6,399 and they just rounded up, or did they actually measure each one of these zeros? You don't know. So we assume that they didn't. You assume that they rounded, and you say there's only 2 significant digits or figures. Now the next one, as soon as you put a decimal there, you're kind of stating that, hey, I actually measured this. I measured also this. I measured the 0, so I know for sure that they were there. It wasn't 6,399. It was for sure 6,400. And that decimal tells us this. So they become significant. So here there's 4 significant figures. And then the very last example is 6.0000. So somebody that's writing these zeros, you really didn't have to write them. So if you're going to go through trouble of writing them, you're stating that I measure them all, right? Like you're not just writing them down for fun, because you don't need to write anything after the decimal. It's assumed to be zeros. But if you actually write them, that means that you actually measure them. So this last example here has 5 significant figures. Okay? So with having said all of that, let's go ahead and write down some rules of significant digits. So the first rule is that non-zeros are significant. Non-zeros are significant. So anything that's not a zero is a significant digit. If I have a zero between non-zero numbers, so if it's sandwiched between, regardless of whether there's a decimal or not, zero between non-zeros, it is significant. Yes, it is significant. And then I have the leading zero, so the zeros leading zeros. So the zeros at the very beginning. And they're just there to kind of hold my decimal in place. If I was to change my my unit of measure, those zeros might be gone if I go from kilometers to meters, or the other way around, I might have to add zeros. So any leading zero is not significant. Okay? So I'm going to put a sad face there. It's not significant. And then the other case is when I have decimals. Okay, so if there's a decimal, so actually this would really be the trailing zeros, like the zeros at the end, because we really talked about the leading zeros, the zeros in between, the zeros in front, the zeros in between, and now what about the trailing zeros at the end? Trailing zeros. If there's no decimal, that means they're not no decimal. They are not significant. So another sad face there. If there is a decimal, so if I put a decimal there, well, that right away changes the game. They are significant. Yay! Awesome. That's amazing. And then, of course, when I said when you have some exact values or measurements, exact values like 1 meter is 100 centimeters, well, they're understood to have infinite significant digits. Sig figs, I call them, significant figures. All right? And this really matters when we start to do calculations, right? Because otherwise you would say, well, why are we even mentioning this exact value when you know it's not really part of a measurement? But it is when we're doing computation. So how do we do computations here? So when you add or subtract or multiply or divide, let's use an example of multiplication. 77.8 multiplied with 0.8967. If I plug this into my iPhone calculator that I'm not really a fan of because, you know, it's not the greatest calculator, I would get, let's take a look, 69.76326. Yikes, wow, that's a big number. So how many significant digits do you think I would keep here? So when you're doing mathematics, you're always going to round to the same. So rounding rule is round to the same. So same number of significant digits, number of sig figs, as the measurement with fewest significant digits. So that means that my first measurement that I'm using here in my calculation has 3 significant figures. And this one here, don't say 5, it's got 4 significant figures. We'll talk about it. So we're going to round to 3. So that means that my 69.76 really becomes 69.8, whatever the unit is. All right? The amount that I said at the very beginning, the exact measurement. So this would only be if I was multiplying or adding. Let's say that I was adding, and I was adding with, let's say, 100 people. So that's my unit, 100 people. Well, this 100 here, don't say that this has only one significant digit because it's an exact value. It has infinite significant digits. And that means that my answer would still get rounded to 3 significant digits, because the value with the least number of significant digits is what we use when we round. So you wouldn't be rounding it to, you know, all the values that your calculator says. Well, if you're multiplying, not necessarily adding, but if I'm adding or multiplying with an exact value or an exact measurement, that's understood to have an infinite number of significant digits. So the one that will limit it is the other number.